says string on a violin is tuned to a frequency 1.5 or 1.5 times that of its neighbor. The four equal length strings are to be placed under the same tension. What must be the mass per unit length of each string relative to that of the lowest string? Okay, well, we are going to call that of the lowest string the fundamental frequency. And for a string with both ends fixed, the fundamental frequency is given by this relationship. We're calling this F. We'll call F1 the fundamental frequency is equal to 1 over 2L times the square root of the force of the tension on the string, Ft, divided by mu. Okay, well, mu here is the mass per unit length. Okay, and we're asked to find the ratio of the mass per unit length. Okay, well, we were told that the frequency of each one is 1.5 times the frequency of the adjacent neighbor. So we'll call Fa the fundamental frequency. That means Fb, the next one, is equal to 1.5 times Fa. Fa is the fundamental frequency, though, right? So we can rewrite this as Fb, which is 1 over 2L times the square root of Ft, because because L is the same and the force of the tension is the same in these two cases, right? But this is mu b. So that's one side of the equation. And the other side is 1.5 times 1 over 2L times the square root Ft. And this time it's mu b. Okay, let's go ahead and make sure this square root extends all the way down to include all that. And then we'll erase that. That looks better. Okay. So now we find that since we'll cancel everything in red, this cancels and this cancels. And then the FTs are going to cancel, right? So what we're left with is, let's go back to black. We find that mu b is equal to mu a divided by 1.5. And this is squared, which equals 4 mu a. Okay, and box that in. So that's one of our solutions. Next, we know that, so now we know Fc, so we want to find mu c relative to mu b, or I'm sorry, relative to mu a. Fc is going to be equal to 1.5 times Fb, because that's its adjacent neighbor. Well, using the exact same logic we just used, we're going to end up with the ratio of, let's do this. We're going to end up with the ratio of mu c is equal to mu b divided by, now let's rewrite that as well to make it look less like an m, mu b divided by 1.5 squared. Okay, but mu b was 0.44 mu a, so 0.44 divided by 1.5 squared is 0.20, and you still have the mu a. This will be mu a. It's mu sub a. Okay, and box that in as this next solution. And then for the last one, again, we have F sub d is equal to 1.5 times its neighbor, which is the frequency of C. Okay, and then using the exact same logic, we're going to end up then with mu d is equal to mu c divided by 1.5 squared. Okay, and then going back to the previous, is mu a, so 0.2 divided by 1.5 squared is 0.88. And then you have mu A. Box that in. It's the last part of our answer.